All right, so talking about standard deviation. Standard deviation, we have our definition here. Standard deviation of a data set is a measure of how much a typical value differs from the mean. So I mentioned in the video on day one that you saw before that range tells us how spread out it is, but only the biggest and smallest. So range doesn't do much for us in terms of the overall data set. That's just the biggest and smallest, right? Standard deviation looks at each individual number and tells us how spread out on average is that data. On average, how far away from the mean or our average is are all of those data points, okay? And so there's a definite process that we have to go through to get there. And you see they've got this that doesn't necessarily make a lot of sense to us and it looks daunting. We'll get into step by step what we have to do. Yes, this kind of tells us what we need to do. But if you're not sure what you're looking at, it doesn't really make a lot of sense. Okay? One thing to point out here, this symbol represents standard deviation. And you see it right here. Okay, it's like a O with a little thing on it. Okay, like a cursive lowercase o. That is sigma. So if you ever see that, that represents standard deviation. Okay? Just in case you come across it. All right, so let's look at the steps that we need to do. And we're going to write these steps down so that we have it. And let's take a couple minutes. Let's just copy these down. Okay, and then I'll go through once you're done writing or almost done writing. We'll go through and we'll talk about what this actually means and how we're going to do it. All right, so let's talk through this and then we're going to take a look at an actual data set and actually find the standard deviation, okay? As I said a couple times, this is a process. It's going to take you a little bit of time. We got to understand what we're doing. Okay, you're going to see it a few times in the homework tonight. On the test, on the quiz, probably just once or twice, okay? Because it does take us a little bit of time. First of all, the X with a bar over it, if you remember or recall seeing that, that represents the mean okay, which is what we call the average, right? So we're going to find the mean, which is represented by that X bar. Then we're going to find the deviation of each data value. That's how far away from each data point is the mean. So we're subtracting the data point from the mean, or the mean from the data point. It doesn't matter which way you go, but you're going to subtract the mean and the data point, each data point. You're going to take that answer, you're going to square it. Then you're going to find the mean of those answers, and then you're going to take the square root at the end. Okay, so we're going to take a look at a data set here, and we're going to find the standard deviation. You need a calculator for it because we are squaring, we're taking the square root, we're finding the averages. You need a calculator for it. So what I'm going to do is I'm going to put up 10 numbers here. Actually, let's do less than that. I'll do 6 numbers. And we're going to find the standard deviation of these 6 numbers. Let's go 6, 10, 4, 12, 4, 1, 2, 3, 4, 5, and let's say 20. We're going to look at those 6 numbers. And we're going to find the standard deviation. And what I'm going to do is I'm going to kind of organize this. I'm going to put it in a chart so that I know exactly what I'm doing. Okay? We represent our data point with the X, right? And that's in our steps. Each data point is represented by X. Okay? So the first thing we have to do is we have to find the mean. We have to find the average of this. So add those all up, divide it by 6. Let's get that average. Get that mean. Yes. Okay, what do we get for a mean value here? 9.33. So let's round it. Let's call it 9.3. Okay. So we're going to say that X bar is 9.3. Okay. X bar is just the mean. So X bar is going to be 9.3. The next step in our standard deviation process, find the deviation of each data value. That's just subtract the 2. We're going to subtract the 2 values. Now, when you look at it in the book, they're going to have it always as this number minus the mean. Okay, they're going to have X minus X bar. That's fine. It does not matter because we are going to square it afterwards. So it's always going to end up positive. So if it's me, I'm not worried about doing 6 minus 9.3 and getting a negative 3.3. I'm always going to take the bigger one, whichever one's bigger between the X or the X bar. I'm going to take the bigger one minus the smaller one, and I'm going to put that number here. Okay, all my numbers are going to be positive in this column. It's going to make it easier. We're not going to worry about negative, and it's completely okay. So that's what I want you to do. I want you to subtract each one of these numbers with 9.3, and I want you to get some values in that next column. Okay, so we can have that next column filled out there, and if we need a calculator on it, perfectly fine. Use the calculator. Well, we should get those. Okay, that's step 2. Any questions about our first 2 steps here? Okay. So then it says to square each deviation. These are called the deviations. So we're going to square that. So we're going to take whatever we had here and we're going to square it, which means just take 3.3 and square it, write it down. Take 0.7, square it, write it down. Okay, so we square those numbers. We get it here. Don't round those, especially if they're only two decimal places. Keep both of them, right? It might throw your end result off slightly if we start rounding too soon. So that's the third one. We're just squaring those numbers, right? Fourth one, find the mean of those numbers. So we're going to take this last column and we're going to find the mean. So again, we're going to add those 6 together. We're going to divide it by 6. We're going to get that mean. We find the mean there, right? We add them all up, we divide by 6. We're going to end up with 31.55666666666666 forever, right? We're not going to use it forever, but we don't want to round it just to like 31.6. Because the more you round during your problem, the further away from your actual answer you're going to get. We don't want to round it until the very end, if we can help it. Yeah, we rounded this 9.3. Our problem would have been more accurate if we went 9.33 or 9.333, right? The more decimal places you keep, the more accurate your answer is going to be. Well, we're one step away from the end. Don't round yet, okay? Leave it for the end. So we get that mean, and then the very last thing we got to do is we got to take the square root of that. We're going to take the square root of that, and that's going to be our answer. And then we can round it. And they'll tell you whether to round it to the 10th or the 100th or whatever. But we're going to end up with about 5.6175. So depending on what they want us to round to, it's either going to be 5.6, 5.62, something like that. Okay, and that's telling us on average, our data points are about 5.5 away from that mean value. Okay. It is quite a process. As you can see, once you get going on it, you get better at it. It gets quicker. I don't have to explain everything every time. It gets a little bit better. Okay. Any questions right now on our 5-step process here? Okay. If I took this 20 and I changed it to 200, what do you think would happen to our standard deviation? going to go up. It's going to get bigger, right? Because this is how far away are all of our data points. The average distance away, basically. Okay, so if I were to take this 20 and change it into a 10, what would happen then? It would go down, right? Because now it's closer to that average, that mean. So the closer all of our numbers are, the smaller your standard deviation is going to be. If I had a data set that was very similar to each other, right? If I had a data set that was all 10s and 11s, my standard deviation is going to be very small. My standard deviation would probably be like a 0.4 or something. Okay, very close together. Okay? Even if I had all of these points, let's say I kept going, I had a bunch of 10s and 11s, and I had one that was a 40. I had one that was pretty far away. I had one outlier. My standard deviation is still going to be pretty small here. And I'm not going to solve it for sake of time here. But that standard deviation would still be pretty small because the great majority of my numbers were there. Now, if I just found the range of this data set, the range of this data set is 30. The range tells me that it's pretty spread out. But if we look at standard deviation, it really isn't that spread out. We just have one outlier. Okay? So that's why we need standard deviation instead of just range, because range doesn't work great all the time. Okay? Range only takes into account two numbers, whereas our standard deviation talks about all of them. Okay? All right, let me show you what the book has down. It's very, very similar to what we just did. They have a different data set. The only difference that they do here compared to what we did, or what I did on the board anyway, is in their chart, they write the mean next to all of them. That just gives them, you know, they know that they can just subtract those two numbers. I don't think we have to write that in, right? We remembered that it was 9.3 and we just subtracted every time. Or we could remember that it's 25 and subtract every time. They had positives and negatives here. Remember, it doesn't matter because we're squaring it anyway. So they did 20 minus 25 to get -5, but then you square it and it becomes positive anyway, right? Whereas you could just do 25 minus 20, get a positive 5 here, square it, and get a 25 anyway. So we don't have to worry about those negatives, okay? All right, any questions right now about our standard deviation? And I know we only went over one example. There's another example in the book here. I'll post the video. You can rewatch that one example and we can go over it. Or you can go over it, you can ask questions about it. But that's the process that you're going to go through. Okay. A couple other things I just want to point out, just because you are going to see them in the homework tonight. Not sure that you saw them over the weekend, but I think it was mentioned in the video. I just want to recap it. The other thing that I want to point out here is this idea of data transformation. Okay, was this in the video from day one? Okay, so it should be quick. Okay, I just want to point out and remind you of it, especially for those of you that didn't really pay attention to the video and just did the homework. There's two different types of data transformations. Either we add a number to every value in the data set, or we multiply every number in the data set by something. And our answers are going to be different, or how that affects our measures of central tendency is going to be different. If I'm adding a number to everything, I take all of the numbers in my data set, I add 5 to all of them. All right, well, the mean, median, and mode, which are the measures of center, the mean, median, and mode are all going to be added by 5. We're going to add 5 to all of them. Whatever you add to every data point, you're going to add that to mean, median, mode. Your range and your standard deviation are going to stay the exact same because they're still the same distance apart. All right, we're just taking all of our numbers and shifting them up 5. Everything's the same distance apart. So you're going to add that number to mean, median, and mode. range and standard deviation going to stay the exact same. If you are multiplying everything by something, you're just going to multiply all of those measures by the same thing. Okay, so if we're multiplying by 5, right? We're multiplying by 5. Every number is 5 is times 5. Your mean is going to be times 5. Your mode is going to be times 5. Your median is going to be times 5. Your range is going to be times 5. Standard deviation is going to be times 5, right? Everything is multiplied. So this one's pretty straightforward. It's the addition one where you got to know which ones we're actually adding and which ones we aren't, which ones stay the same. Okay? You're going to see those questions in the homework tonight. Just wanted to recap that and make sure that we have. Okay. Any questions right now about anything that we talked about? No. Nothing for people at home. I'm assuming that you're paying attention. If you're not, that's not great.